Hi everyone, the contest has just started. Is it a 2 hour 30 minutes contest? See, I'm having 3.6k subscribers. Motherfuckers, whoever are watching my streams, subscribe if you're not subscribed yet. Okay? Even if you don't watch it consistently, why not subscribe? Right? So just subscribe, okay? I got a pimple type of thing inside. You're given a permutation P of size and you may perform the following operation any number of times. Choose a subarray of size 3, delete either the smallest or the largest element within it. For example, the permutation you may choose this, you can delete 5. Uh, for each I from 1 to n, find the minimum length of an obtainable array that contains the number pi. So is it mostly 1 or 2? I think 2 is always possible, I guess. 2 is always possible. Right, because if the size is greater than or equals to 3, you can always remove something that is either lowest or the highest. So 2 is always possible. When is 1, you have to just think about that. When is it 1? Right, you have to choose a subarray of size 3. So when 1 is not possible. So if n equals to 1, then 1. Else 2, 2, 2, 2 is the answer. That's it. Seemingly weird problem, right? Oh, these are some new colors. Will it pass other test cases? Just think about that for a minute. 2 is always possible. And the fuck, I'm registered, right? Okay, let me go to B. Given an array, let f of a be the number of ways to partition it into one or more subarrays such that each element appears in exactly one subarray. All subarrays have the same sum. For example, yeah, you're given two integers x and y. Find the minimum value of f of a for f of a is number of ways to partition. They're asking find the minimum value of f of a over all arrays a of length x plus y, consisting x copies of number 1 and y copies of number minus 1 in some order. Since the answer may be very large, output it modulo this. Additionally, you should construct one array that achieves this minimum value. See, they're asking us to do more, but it should be simple. Right? We have x plus 1s and y minus 1s, right? Total sum equals to an x plus 5. Sum of x, it's guaranteed that sum of x over all test cases does not exist, sum of y does not exist. So let's just try to say whatever we can say quickly. Okay, total sum equals to x minus 5. Okay, this is fixed. Total sum is fixed, and if you split into z partitions, see, if the sum is fixed, that doesn't mean the number of partitions will get fixed, because maybe it is placing ones in the beginning and minus ones at the end, or maybe something else. Find the minimum value of f of a. So we want to have minimum value of f of a, number of ways to partition an array into one or more subarrays. So if we are splitting into z partitions, z should divide, then you can say z divides x minus 5. Okay? And after this, whenever some subarray is like of some 0, you can either add that to this side or this side. So we have f of a and then we have that. Maybe we can always make f of a to be something so small, I guess, maybe. Because let's say if total sum is greater than 0, then place all the minus ones at the start. Okay? Then what happens? This cannot be a subarray because total sum by z equals to the value, right? Total sum, all of these must be there in one thing. And after that, you should add all the plus ones to make it at least positive first. Okay? So now it is 0. Now you have plus 1, plus 1, plus 1, plus 1, plus 1. And if this is 0, you can split this into O of division number of ways, but that is too many ways again. Can you make it either one way or two way if you think of it? But is this a lower bound? Is this always possible if you think about that? Is this always possible to divide this into sum by that? If you think of that, uh, that is the total sum, right? And if you take total sum divides, like what I'm trying to say is this can be divided in that many number of ways, right? And is that always possible is what I'm trying to question now. If that is always possible, uh, because that is the total sum that is possible, and values will only go plus or minus 1, plus 1 or minus 1. That means everything in between should be achievable if you are going over prefix sums. If everything in between is achievable, then there are splits definitely. So this is the way. This is f of a. F of a equals to number of divisors of x minus 5. That's it. That's all it is, and you cannot do better. And placing bigger minus ones here and that will always be sufficient. So we want number of int int sum equals to abs of x minus 5, let's say. Okay, f of a value will be number of divisors of this one. Fa equals to 0, let's say. 2, 0, 1, 2. Okay, if sum equals to 0, maybe 1 is the answer. The first time you form 0, from there it matters, right? For sum equals to 0, fa equals to 1. Okay, we are still stuck. So let's read C1. So let me submit A. Let me submit B. See, we did very clear proof. If you see all the prefix sums, they change by plus 1 or minus 1. If they're changing by plus 1 or minus 1, they achieve D, 2D, 3D, everything they achieve. So it's surely right. This is an easy version of the problem. The difference between the versions in that is that in this version, the array A is guaranteed to be a permutation. You can only hack. Uh, the difference between the versions is that in this version, the array is guaranteed to be a permutation. You can only hack if you solve both the versions. So C2 is A is arbitrary. C1 is this is that. Given an array of size and a parameter k and an array b is called cool if the following conditions hold. For each integer, for each I from k to n, the array is a. So starting from k, if you look at this from 1 to k, for all of them, the k-sized array is a rearrangement of this. So we want them to be a rearrangement of this. For all it should happen. You're given two arrays A and B of size and an integer k. The array is guaranteed to be a permutation, and array B contains only integers from 1 to n and minus 1. Determine if it is possible to replace all minus 1 in B with an integer from 1 to n such that B is cool with respect to k. So we have to determine if you can make that cool or not. So first we have to once a bit study what it means to be cool with respect to a comma b and k. Right. So what can you say? This and this all k length subarrays or rearrangements of respective k lengths in B. So A and B are almost same type of thing, but they are like a bit of rearrangements. Okay. So if you see this and this, the count of values will be equal. Okay, the count of values will be equal. So just let's look at x, y, pq. Okay, count of values of minus x plus y equals to, so if you look at like count of frequencies counts, okay, let's frequency counts of s of a equals to that. S of u minus x plus y is same as s of b. So what it means is, see, this and this are equal and this and this are equal, which is nothing but minus x plus y equals to minus p plus q in terms of what has gone and what has came. Right. So if these two are 0, then these two also should be same. That's the condition. If this condition holds for all k, then also we are done, because if this condition holds for all k, then also we are done. Like for k greater than for I greater than k, if a of I minus a of I minus k equals to b of I minus k. If this, should this hold for all? Think of that. This should hold for all. This should be true because take any two adjacent subarrays. This must be true. This is true. And if this is true, is that enough? Think of that now. If this is true, is that enough? And a of 0 1 to k is a rearrangement of a of b of 1 to k. See, both of them are necessary conditions, but they're also sufficient. Okay, because if the first two things are matching and then this one happens, then the next two things will match, and then the next two things will match, and then the next two things will match, and then everything will match. So if you try to simplify this shade, you can just simplify that shade into just this one, which is nothing but this and this. So now you have to only think in this sense, okay? So if you look at these things with respect to reminder k or k plus 1, with respect to reminder k, all these things follow, all these things get splitted. If you look at that with respect to reminder k, you see, and then the question is, so this is true with respect to reminder k, these things will get splitted, and this is some other condition. Okay, leave this condition, this is some other condition, and with respect to reminder k, all these things get splitted. Now let's look at this condition. Okay, for some reminder k, one value is going and one value is coming, so they must be identical is what I believe. If you look at here, 1 2 3 4, see, 3 and 3 are identical, 1 and minus 1 are identical, and then we don't have anything else, because these are like frequencies. Now if there are frequencies, either either these two are equal, then they can be anything, or if it's like some minus 1, some plus 1 and minus 1 in a vector, okay, and each value is different, and if each value is different, if a of I not equals to a of I minus k, if a of I not equals to a of I minus k, so these are not like normal subtractions, okay, these are like this value, these are like subtractions in terms of frequencies counts. Like if you see frequency vector, frequency array, this value is having plus 1, this value is having minus 1, and that equals to this thing. So if these two values are different, they must match with these two values. Then b of I equals to a of I, and b of I minus k equals to a of I minus k. Okay, and let's look at the other thing now. Okay, what if these two things are equal? What if these two things are equal? Even then, if these two things are same or different, they must be equal, because if these two things are equal, their frequency is gone, so now these two things should be equal. So what we are seeing is, in this chain of reminder class of some reminder with respect to k, if you see this chain, for that chain, either these two things are equal, 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 and so on. Either these two things are equal, 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 and so on, or these two things are equal. Okay, and these two things can be equal and different. Now these two things are different. And now when you try to compare these two, it's again, if a of I not equals to this one, then b of I should be equals to that, and that should be equals to this. And now if these two things are equal, all of them are equal, then all corresponding values are equal. Now if those two things became equal, then these two things also should be equal. Them being equal to this or not doesn't matter. Okay, now let's see the next one. If these two things are different, or if these two things are same. Because if those two things are same, then let's just put them here. Okay, if those two things are same for some I, then they will be same for all the remainder class. That's one fact, right? So if those two things are different for somewhere, then you can see that they should be equal. So it's these two things, it's just these two things. Either this remainder class is same, or this remainder class is equal in both arrays. Do you get what these conditions are now? An array A is fixed. So if array A is fixed, this shit becomes so simple, right? Because if the array A is equal, then B can be equal and anything. Okay? So array A is fixed, so B can be equal and anything. And if array A is fixed, right? So in if array and if an array A, if it is not equal, then B must be that. So B will be fixed for all the remainder classes where array A changes. Uh, because those are the only two possibilities, either all equal or like all this time this side matches, either all the rows are same or all the columns are same. That's the condition here, right? And if all the rows are same, we will check that for array A. And if all the rows are not same, then all the columns must be same, and all the values of B can be filled. And once you fill all the values of B, and then you have if all of them are same, then these columns can be anything. So in the very beginning of in the first k elements, now we have some things which are already got filled, and we have some things which can take any value. And if you look at the things which can take any value, you have to see that other things frequencies are less than or equals to above other things frequencies, so that you can fill that and then it's done. I hope I'm right. I'm actually solving both the problems at once. I don't know how being in permutation helps us here, but I'm actually solving all the problems together. All I want is if they are equal or not, right? If they are equal or not is what I want. Now they are not equal. Okay, now they are not equal. And if they're not equal, then all the values of b will become fixed. Because think of that again, these two should be equal, and if these two are equal, those two are equal, those two are equal, because if these two are not equal, these two will also be must be the same. Okay, now we have filled all of them. Now we have filled all of them, and we have filled for all the remainder classes. Once you have filled it for all the remainder classes, okay, b of j might still be minus 1. Some of b of j's might still be minus 1 because that remainder class hasn't been touched at all, let's say. And if it hasn't been touched at all, what you have to do is you have to see the frequencies of all the characters in a should be greater than or equals to frequencies of all the characters in b. Okay. Frequencies of a of I plus plus, let's say. And if b of I not equals to minus 1, frequencies of b of I minus minus. And what we want is we want this should be greater than or equals to 0. What have happened here? So if all of them are equal, then all of these things can be equal, and they can be anything, but they must be equal, right? But if they're not equal, then they'll get fixed. See, other than minus 1, count of other than minus 1, okay? Or let's just keep val. So if there was something, then everything should be that. Now, if you look at anything, Okay, now here minus ones might remain. In this case, here minus ones will remain, or the values will remain. And if all the values remains, then we will finally check the count. This time it should be better. And I think I have done it right. I have done it right in a way that C2 also will pass with this solution. I don't know how C1 and C2 can help each other, but let me just see. Let me just see C1 getting passed, and I'll be ready with C2. Logically, my solution is perfect for C1 or C2, right? So I'm not scared of C1 or C2. I think both are same in the way I solved. So now let me go to D. I don't know how good am I doing or I don't know how bad am I doing, but let me go to D and try to solve D. For a sequence here of length, and we define an array for a sequence for a sequence A of length, and we define its AND array f of A as follows: f of A of k equals to take AND of any subsequence of size k on their summation. Okay, that's f of A with a suffix k for all 1 less than or equals to k less than or equals to k, and where AND denotes the bitwise AND operation. In other words, f of A of k is a sum of bitwise and over all subsequences of A with length k. Given a sequence A the sequence A is unknown to you, however, you are provided with a sequence B of length n such that B of I equals to f of AI of modulus of 1 plus 7 for all 1 less than or equals to that. Your task is to construct a subsequence A based on the given sequence B. It guarantees that there exists a sequence A of length n such that these are the constraints on the inputs, okay? Okay, this C is having solves. So this is also having solves already. So it's not that difficult problem, but because it is bitwise and it's all about seeing one bit, I think, right? One bit at a time, because the summation is f of A is completely dependent on one bit, because the summation is will get split across bits, right? So that is definitely related to one bit. And then the sequence is unknown to you, however, you're provided with the sequence such that bi equals to f of A of I mod 29 plus 7. So we have to reconstruct our sequence, it seems. Have a sequence. Rearranging bits inside that sequence doesn't change anything, right? If you have a sequence here, or f of A of k equals to bitwise, if you see bitwise, let L C k times 2 power I. For each bit, the number of active bits in there, from that, if you take this ck, you will get that value. And then you have this 2 power I. Because these are 2 power s, can you somehow find this L of I? Because you are given k equals to 1 to n, how can you do this? Because you were given k equals to 1 to n. Try to see subtraction from f of a minus f of a minus k. If you subtract, I don't think we can split the modulos based on this one. If you know f of a of k, but you know f of a of k minus 1, you know f of a of k minus 2, you know f of a of k minus 3 and everything. Right? Add them up, maybe. Let's just add them up. What will happen then? What is this? Among L minus 1, choosing k things. Number of distinct ways to do that. Because and is nothing but choosing k things. If all of them are present, only then you will get that, right? 1. So if you add them up, what will you get? Choosing from L of I choosing 0 things, L of I choosing 1 thing, L of I choosing 2 things, L of I choosing 3 things up to so on, L of I choosing n things. You will get 2 power L of I times 2 power I. What if you subtract each of them? What if you alternate sum them? You'll get 0, huh? Wait, if you subtract each of them, we'll get LC1 minus LC2 plus LC3 and so on. I don't know how can you filter things from reminder class. And let's say suppose somehow L greater than Z has been removed, you know their value and you have removed them, let's say. Okay? Now you want what are all the bits that are there in this one. Right. Now we want what are all the bits that are there in this one. Somehow you removed all the bigger lens. Then everything smaller is 0. And all these things will become 1. You have precisely the sum of bits in 2 powers with respect to modulo m. And then for next step, you know this these bits take length equals to z, so you can remove their contribution by removing zci times their hash. Now only problem that's left is given some 2 powers with respect to m modulo, can you retrieve the bits back? Only this is left. This is only the problem that's left. If you can come from above, come from that side, and then you can come from below, above side. Given some 2 powers, can you retrieve the bits back? Maybe you can't, but you can have hashes of all the values. Now if you have all these hashes, now can you determine that? If you can determine what hash is even and what hash is odd. But wait a minute, these values are less than m, so the modulo is same as their value. Those values are less than m, so the problem is done. I can implement it right away. Just have to come from the above side, and then you have the number of bits, the number of hashes for each of them, and then because if you know the hash equals to the modulo, right? All you have to do is come from z equals to max, and you'll know the hash value, and then you'll know the count, and then you can just write that back, right? But how do you remove the influence of above things quickly? How do you remove the how do you remove the influence of above things quickly? Is because how can you do that is if a length is having some hash that cannot happen more than modulus of 30 times, right? Because that cannot happen more than modulus of 30, not modulus of like with an upper bound of 30 times, you can just go over them and you can just remove. So you want non-zero hashes. You want non-zero hashes on their lengths, okay? You want non-zero hashes on their lengths. So let's just maintain them in a vector. So try to see only the values, only L equals to Z remains here. And the value itself is hash. But what we should be doing is we should be removing the bigger lines from this one, okay? What we should be doing is int hash equals to b of z, okay? Start from here. And then what do? You iterate over values in already collected bigger hashes and then you know their length, okay? I mean, I like CP. Like, I like solving these problems. Otherwise, why would I be doing? Like, I'm not even chasing any goal. You guys have seen me not registering for a contest. I like streaming too. I like streaming too because I can say something and it looks cool to say, and I can get subscribers. I can get fame in future. I can get more girls with that, right? Uh, where am I again? And in this previous hash, now what do? We have to remove this based on LCZ. We have to remove LCZ from this shit. Okay? 29 plus 7. You want factorials? For how long you want factorials? You want till 1e5 it seems. So you should just remove minus equals to prim hash times NCR of L comma Z. It's as simple as that. Just come from above, remove shit. That's what the problem is being. Now actually you can just go over and then you can just fill the array too. Okay, you can fill the array actually. How do you do that? So if this happens in hash, if this bit is active, what do? You activate that bit for z times, okay? That's it. Actually, I got the solution immediately, but then I thought it can be this easy. If it passes test one, it passes remaining things, right? Let me just submit once. It need not be unique, we know that. Okay, this was quite direct, but I have complicated it a bit. I have complicated a bit. I mean, my the ideas I used were a bit complicated. It was being very direct. Even I thought coming from above things will give us values. Okay, this was quite direct. You just have to come from above things, then you can know what are the hashes in each of them, and then you can remove them. I was contemplating, I was spending more time because I was trying to think about how can I retrieve the bits back from the reminder. But if the modulus is big enough, I mean, if the thing that you're taking remind, fuck, fuck it, fuck it. I have done the proof why it will be small, and then I missed it. Fuck. I have done the proof and then I got it early. Why do I do this? Why did I do the proof to implement it, right? Why did I do the proof? I'll get some water because I'm shouting. Oh yeah, it accepted now. N square versus O of 30 times n. That's the difference in time complexity. But yeah, many people are solving. So this is easier than this, it seems. Where am I standing? Decent. So also I should go for F if F is having much more passing rate, right? I'll read this one too, but yeah. It's an interactive problem. I like interactive problems. Too. Learning binary search. You step into your first data structures classes where you are learning about binary search. You heard the professor yapping about why binary search works in of log n. But you want to see if you could find a better bound. Given a sorted array of length of size n and an integer k, define f of a of a comma k comma l comma r as the result of the following code. If a does not contain k, return 0. How do we know that? Mid equals to floor of L plus R by 2. If A of mid equals to K, return 1. If A of mid less than K, if A of mid is less than K, so it is like at what level it is present, right? F of L comma R, if it is present in the exact mid, it will be 1. But if it is not present in the mid, but it is present in the next split, let's say, then it will be that 1 plus in this one where it is present, in what level it is present. So it gives us in what level it is present in, some kind of what level it is present in, okay? You're given two integers n and m, define an array a good if modulus of a equals to n, 1 less than or equals to all the values less than or equals to m. You're interested in finding the sum of f of a of 1 comma 1 comma n plus f of a of 2 comma 1 comma n up to so f of a of m comma 1 comma n over all good arrays a. 6 7 6 7 6 7 6 7 7. See, the problem asks you for something, and the problem is solvable. Okay? So, what you have to do is try to solve the problem. You should not think of any other thing. When the previous problem was nothing but coming from above and subtracting things, how complicated can this one get? Okay? Not that complicated, right? It cannot get that complicated, right? I'm just adjusting my balls, let's say. I should be doing calisthenics videos. Would you guys like it if I do them? I want likes. I want more people. So what do you mean by level? If you keep splitting things like this, like this, like this, first time k occurs in some level, right? If a of mid is greater than or equals to k, we go. If a of mid is greater than k, yeah, this is nothing but the first time it occurs in somewhere, right? The first time it occurs somewhere. So if it is not occurring here, it will occur here maybe, and then we will go here. The first time it occurs, the first time the value k occurs in this split edge, the level where it occurs. If it doesn't occur at all, the value is zero. If it occurs in some level where the first time it occurs, that's what the value of f of a of k or comma l comma r. But if you look at a given structure, if you fix one and n, if you fix one and n, this structure is fixed, isn't it? If you fix one and n, that structure is fixed. If you fix one and n, that structure is fixed, right? Sum of n and sum of m does not exist 1 in 9. But n can be more, m can be more, n and m can be n can be less, m can be more. You have to do it in O of n plus O of m. Okay, now the structure is fixed, and if the structure is fixed, can you somehow find the structure is fixed? Number of levels is low, but for each level there can be multiple good things, possible seats. Okay, this is the structure, and for it to take its seat but not its parents, something should happen, right? Let's say if it is taking this seat and it's not taking its parents seat, we should also say that that should start after the parent, but before, but it should start, it should cover this one. It should start after the parent, but it should cover this one. So for all these things you have, it should start after the parent, but it should cover this one. So for each seat, you have something like, you have it like either you have it like you have a bound. That bound just doesn't depend on its parent, but it depends on its parents, and everything, I believe. You have a bound. You have a bound. You have a bound. You have a bound for k. Okay? As you go and travel from above, if you come this side, what does that say for this seat? The value should start after this. That's the bound. Okay? And if you go this side, the value should start before this. So whenever you come to this side, you have this left side bound. Whenever you come from this side, you have this right side bound. So let's say you came this side and then you came this side. To just visualize better, if you came this side means you have this bound. Actually, the bound is quite simple. If you are having this one currently, it should not go behind this, because if it is going behind this, it will have its parent. If it will have its parent, who's so it should be within this itself. It should be within this and come here. Okay, it should be within this interval and be here, because if it crosses that interval, it will be in the parent here. If it is crossing that interval, so the bound is it should be present on this one, and it should be within this one. That you have to count. So k should start from here and should end before this one. K should take some subsequent till here, and then you want the value of that, and you want this summation over m equals to 1, 2, 3 up to so on, right? Let's say x be the value. If x is falling from this is x, and x should start from somewhere here. X coming till here, x coming till here. The first x coming from here, the first x coming from within this, the first x coming from here, the first x coming from here, the first x coming from after. If you know the first x is coming from here, and if you know the first x coming from here, you can get the first x coming from here. If you subtract those two things, you can get first x coming from here, but ending after that. And actually, you can compute this shit in O of n. O of this length, you can compute this shit in O of this length. Why? Because each of them occurs in at max log n levels, right? So you have that much of power with you, that much of power with you. So let's have something like start from here, but stay within this one. Okay, start from index I, but stay within this one. Okay, so now you have this one, right? Starting from this one. So this is x. This is x. What about the remaining things? Let's not even fix X and let's try to see that a bit more clearly. All you want is for a partition to fall here and for that partition to end here. That's all you want. You don't even mind. You don't even care. You don't even care. What are the partitions before and what are the partitions after? All you care about is there is a partition here, there is a partition here. That's all you care about. That's all you care about. You don't even care about the value. You don't even care about the exact value because over summation, you don't care about the value. All you want is there should be a partition and it's all about partitions, right? It's all about partitions, right? If the count is zero, partitions fall in the same place. So it's all about partitions. If the count of something is zero, partitions fall in the same place. And then what do you want? What do you want is what do you want? I'll smoke a cigarette after this. I'll go out, I'll walk, I'll maybe listen to music. I should be careful while listening to music on roads because what if some car comes and hits me off? I know I can act like a Spider Man. I know I can black flip onto the top of the car and then swing something and go to a pillar. But what if my spider sense doesn't activate because I'm using earphones? What if? You guys will get no more streams? Nah, I don't think a car can do anything. Car will get damaged because I have like this iron body, right? That I train calisthenics and gym and shit. So you have one, two, three, four, and so on. N. Okay? Values can fall and you have you have m partitions, m minus 1 partitions. Okay, you have m minus 1 partitions. You have this 1 2 3 4 up to so on, and these are circles. Let's say this is star bar problem. I don't know the fuck it is. I learned it long back when I was a hey bro. I'm writing contest. I will call my back after 10:30 or so. Bye. Yeah, yeah. Listen to me. Listen to me. Just one sec. Bro, I'm my recording. Phone's not on. My phone's not. Hi guys, I'm back. So see, if you see below this will take value 1, in between this will take value 2, in between this will take value 3, up to so on. So these things will define everything. After this will take value m. So these things will define everything. Now you have a range, okay? We have this range. All you want is, let's say some circle is here, okay? All you want is, you want, so how many partitions are there? You want something, some partition to be after this. After this you want some partition, because you cannot have the last partition here. That's one rule. So some partition should be after this, some partition should be after this, and before this. Let me also make this as well. Some partition should be after this and before this. So among this you should have one, at least one slash. And among this you should have one slash. That's the condition. That's the condition. That's the condition for this being counted for some value m as its k. So now how to compute this one? You can do O of n. It's very simple. You have in these arrangements, you want one slash to be from here to here and one slash to be from here to here. Wait. It's being very clear, isn't it? If there is no slash from here to here, all these things are like one thing. And you can compute that all of these are one thing, like all of them are one big O, and then you have remaining things. So hear me out. You have left side, you have right side, and you have the whole thing, right? So let's say there is no slash in this left side as one set of uh, orderings, and there is no slash on right side is some other set of orderings. What you want is, for these two sets, you want to look at their union, and then you don't want that shit, because their union is either this is going or that is going, right? And then you don't want that shit. These are the bad things, right? So you want, and how do you compute this? None of them is having one thing is easy, none of them is having one thing is easy, all of them are having nothing is easy, and you have solved the problem. And you have solved the problem. It's one big O. It's one big O. It's one big O. For the border cases, you can always assume that there is a O here and there is a O here, maybe. Don't care about the border cases, okay? Border cases, I think you need not care about that. For that, it's always partition, okay? You can deal them separately, okay? You can deal them separately. Okay, if this length is L1 comma L2, now let's just formalize this one and then we are done. L1 and L2, okay? What is set L equals to left side failing, okay? R equals to right side failing, okay? L intersection R is easy to find, which is nothing but all of them should be together, okay? There is no partition here, and all of them should be together, which is, see, if there is no this one, it can never fail. It can never fail, right? If there is no this side, it can never fail on that side, okay? If there is no this side, it can never fail. And if there is no this side, it can never fail. Plus L2 things on this side. So we are making all of these balls together. We are making all of these balls together. Right? All of these balls you are trying to make together. So if it has to fail on this side, you will make all of these balls together. So total balls will become, total balls will become L1 plus 1 plus L2 plus 1 plus 1. All of them L1 plus 1 plus 1 plus L2 plus 1. These many balls has been replaced with one ball. So total balls will become this much. And then you know the formula. The formula is nothing but n plus m minus 1 c m minus 1. Balls plus m minus 1 c m minus 1. And the ball's value is being changed. L equals to these things being together. Balls minus of L1 plus 1, L1 plus 2. If this is not there, it will never fail. I don't, and I don't want the world to see me, 'cause I don't think that they'd understand. When everything feels to be broken, I just want you to know who I am. So what we want, failing either here or here. You want to subtract that from. Wait, I'm not even doing O of n plus O of m. Am I doing something wrong here? Okay, I'm doing O of n plus O of m. Oh, I'm doing O of n, but I'm not doing O of m. I'm not doing O of m. Lady, running down to the riptide, taken away to the dark side. I wanna be your left hand man. Maybe O of n plus O of m is being done in terms of balls plus m minus 1, c m minus 1. Maybe in this you're doing that. Maybe in calculating the factorials you're doing that. I love you when you're singing that song, and I got a lump in my throat, cause you're gonna sing the words strong. And then what do you want? You want total minus either here it's failing or here it's failing. And you can calculate that by failing here or failing here minus failing in both sides. I don't want the world to see me, cause I don't think that they'd understand. But everything meant to be broken. I just want you to know who I am. Int together of L comma R. Let's say if L comma R is together, what is the value? This is what, okay? L comma R touching something else. This is what we want. If L equals to 1, total minus, see, this can never fail. Now from L2, you can have all of them together. That's the problem now. All of them being together is the problem. Okay? So 1 plus L2 plus 1 being together is the problem. 1 plus L2 plus 1 being together is the problem. And I don't want the world to see me, 'cause I don't think that they understand. When everything's fake to be broken, I just want you to know who I am. Now, what's the problem? On this side, you don't have anything, it will never fail. It will never fail. So, if it is failing on this side itself. An answer plus equals to h times count. Maybe you can find all this NCR with respect to m minus 1 prior itself and store them instead of doing it again and again. Maybe that will be a bit faster. But we have 2 seconds. Let me see. First, let the solution be right. Now, and I don't want the world to see me, 'cause I don't think that they understand. For 1 comma 3, answer equals to 10 it seems. Wait, aren't they symmetrical? Aren't 9 and 7 b should be symmetrical? They should be symmetrical, right? And I don't want the world to see me, 'cause I don't think that they'd understand. number of things that violate one is 1 2 being together, right? And then you have 3. Now, number of things that are possible. You have two more of these things, right? One, two, three, four. It is 4C2 equals to 6. And if you put 6 here, I don't want the world to see me, 'cause I don't think that they'd understand. Count should be 10 minus 6 equals to 4. And answer would be 4 into 2 plus 10, which is equals to 26. And the answer should be 26. Yeah, my logic is right, but something is going wrong. This should be 6. Ah. Why did I make such a mistake? Why did I take so long? And I don't want the world to see me, 'cause I don't think that they'd understand. When everything feels like a. It is passing. Fuck, it's failing finally. It's failing for bigger values. Let's see if this passes or goes TLE. Cause I don't see me, cause I don't think that they understand. When everything feels like that everything's made to be broken. I just want you to know who I am. What have happened? What have happened? What have happened? What have happened? It's just this the answer. This is just this the wrong submission. But why haven't I figured this out before? Am I not optimized to get highest score possible? Am I not designed to get highest score possible? Passes because I can't handle this pressure. I can't handle. I'm an old guy now. I'm not a kid, and I don't want TLE now. I don't want TLE. Please just pass. Please just pass. I'll try E. I'll try reading E. I'll try giving my best on E. Okay. Just pass. Please just pass. Okay. It's a simple problem, but it involves some combinatorial ideas. But all of them are easy peasy for me. Right. I tried fixing X, but then I tried seeing it a bit more. Okay. Why can't I see it irrespective of X? And I don't want the world to see me, 'cause I don't think that they'd understand. When everything feels like a person, I just want you to know who I am. Okay, I will try E. I'll try giving it my best. Given a rooted tree T of size M where each node I has an associated value AI, define a vertical path as a sequence of nodes S1, S2 up to so on SP such that Si plus 1 is the child of Si. For all 1 less than or equals to I less than P, a vertical path is good if GCD of all the values is not equals to 1, means something divides all of them. Define f of t equals to the minimum number of good vertical paths such that every node is in exactly one path. Minimum number of good vertical paths such that, so yeah, f of t equals to, so it's f of t equals to minimum number of good vertical paths such that everything is in one thing. So you can have f of t equals to n in the worst case where each path is at one, but you want that to be minimum. So among all possible partitions of this children comma thing where all of them are good, you want the minimum number. There is a strange rooted tree of n nodes where node 1 is the root. The tree satisfies the property that each node only has children with labels greater than itself. You note S of u as the subtree of node u. That is, S of u contains all nodes v such that the shortest path from the node 1 to node v contains node u. All edges where both endpoints are between such nodes. You are interested in finding f of s of n, f of s of n minus 1, f of up to so on, f of s of 1. Okay, you want to logically find this minimal partition, minimal path partition, minimum path cover, where the path or GCD is not equals to 1. And you want to find this for all subarrays. Okay, you want to find this for the whole tree, you want to find this for all the values. However, there is a magical oracle that is hiding information about tree from you. Specifically, the oracle only tells you information about vertex x after reading the result of f of x plus 1. In other words, you must solve the problem online, starting from node n and ending at node 1. Did they mean f of s of x plus 1? So what should you maintain for each node? Okay, for each of the subtrees, what you should maintain so that once you've given a new node, you will be able to find the answers immediately is the question, okay? Some subtrees will be separate, but this points to some subtrees nodes. When new node will come and point to some subtrees nodes, and then you should be able to find its answer immediately. But how do you do that? How do you do? What's the structure here? What's the optimal structure here? Can you be brute forcing things? You know, values. Each of the values are having variables. We have multiple things here. We have the below things will have higher labels. We have that below things will have higher labels, and okay, if you're trying to brute force this one with respect to these children now, and if you're trying to do with this, if you're trying to connect this to these children, then all of the other things are independent. Now, if all of the other things are independent, you have their optimal answers. Plus, you have to find here now. If these two things are together, the GCD might have been affected. And if the GCD have been affected, and I don't want the world to see me. Cause I don't think that they understand when everything's meant to be broken. I just want you to know who I am. If you connect those two, it's like DP itself, but you have to do it in an online fashion is what they are trying to tell us. Okay, you don't connect them, then the answer equals to 1 plus f of minimums. Now can you do better? Now can you do better? And I don't want the, and I don't want the world to see me, 'cause I don't think that they understand. And I don't want the world to see me, 'cause I don't think that they'd understand. My heart's beating. I don't want it to pass. I'm fine if it doesn't pass. I'm fine if it passes too. Would this have been the right answer? Would I have made some mistake? Would I have made some mistake? I want all the primes to be possible to be the GCD while that being the optimal. And to maintain that primes, I may not be able to maintain the primes, but I want that primes to be present in one of the values that are groupings of primes. Okay? And if I have such a groupings, and I want to make new groupings and I have a new value, GCD of those are the only primes that are allowed now. And I'm taking GCDs and I'm only pushing them and I'm pushing them only if they have something new, if they have some prime that is new. Not yearly, please, because the values are bounded by number of primes that can divide an A of B. See, each push divides AB, and it will have a new prime, and that cannot happen again and again. Please no TLE, please no TLE, please no TLE, please no TLE. Why is it getting stuck there? If it is TLE, my solution is perfect. I just have to see if there is no error in this or not. Once this is the optimal, else this is the optimal, and all the primes have been pushed already. You need not push anything else now. But if nothing has matched, you are trying to push this now because that's the new optimal. Okay? And I don't want the world to see me, cause I don't think that they'd understand. But everything's meant to be broken. I just want you to know who I am. I mean, this is not a difficult problem, but I have achieved it within time. If it passes, I have achieved it within time. That's something great. Because I could have given up here, thinking that I may not be able to solve in the rest of the 25 minutes or 35 minutes. I may not be able to solve by saying the solves being low. But then I haven't done that. I haven't gave up. I tried going further. I haven't lost. I hope it doesn't get fail and it actually passes. I hope it actually passes. See, this could not have been a wrong answer on test 2. This could not have been a wrong answer on test 4. I have already faced good enough losses here in this contest. I don't want to face it more losses. If this one passes, you can see the solution being so simple. Solution being so simple. Only two possible values for the optimal, either sum of its children or 1 plus sum of its children. And if it is sum of its children, what are primes that are possible? Because a prime is enough to debunk GCD not equals to 1, right? You don't need multiple primes. You don't need the maximum thing that's there. Just a prime is enough. But to collect those primes, the optimal way to do is to group them, because you cannot have individual primes all the time. But you want to group them, you want to connect all of them somehow. That's what it is. I hope it passes. I hope it doesn't get yearly on test 23, 21, or test 24. I can't even edit it now within this 50 seconds. And I don't want the world to see me, cause I don't think that they'd understand. When everything's meant to be broken, I just want you to know who I am. Is this my day, guys? Have I done good today? Should I get some water and calm down and chill down? I don't want a wrong answer now. I want it accepted. Please. I don't want a TLE. I think I have done good. I wrote a simple code to find the primes that are new. Just keep removing the GCDs and then you have the prime that is new. And I don't want the world to see me, cause I don't